Hey folks, this is Greg Quiggle, Vice President of Product Management from Kratos, and today I'm excited to talk to you a little bit about what's cooking on with our digital ground strategy. So as many of you probably know, we're really in an era of exciting times with space. Mega constellations, in many cases with hundreds to thousands of satellites or beams, hybrid networks that span between LEO, MEO, and GEO, some even including inter-satellite links, software-defined payloads optimized for pseudo real-time changes in network supply, changes in demand, changes in threat, and even quick-turn mission-specific small sats and CubeSats. So really exciting times in space, lots of innovation, lots of growth. Ultimately, though, that's leading to a crucial need for a new ground system. So today's ground systems really are built around large fixed geo networks. And because of that, they're ill-equipped to deal with this explosion in bandwidth, performance, and flexibility. And you can see that in some cases just based on their design. So, in many cases, if you walk into a ground station today, you're going to see a hardware-centric network that's pretty rigid and static. Typically, it's dedicated to each individual feeder or user beam on a satellite. Because of that, the concept of operation is typically pretty siloed. You have many different organizations within a satellite operator or network operator that invoke manual processes independently to run the overall network. You also have a complete lack of multi-vendor and multi-operator interoperability. And last but not least, you see limited to no integration with terrestrial networks and satellite payloads at scale. So one way to think about it is, the world's moved on to 5G, but today's ground systems are really stuck in 2G for the satellite industry. So what we have cooking at Kratos is really trying to drive a future ground system that's intended to address this gap and ultimately scale with the huge explosion in bandwidth, performance, and flexibility. And we do that really by a pretty simple process. The first thing we do is we generically digitize all of the uplinks and downlinks associated with the gateway. And we package that RF, those digital samples, into an RF over IP standard called VITA 49. Once you've done that, that really allows you to look at the aggregate bandwidth of an up and a downlink and all the subchannels associated with that bandwidth as really a big Ethernet network. So you can manage the bandwidth and channels together in a very similar to what you would do with an Ethernet network. Once you've done that, then you can really migrate from these hardware-centric implementations for common components in a ground station and replace them with virtualized network functions. Good examples would be frequency converters, channelizers, combiners, modulators, demodulators, spectrum analyzers. All of these things today are classic hardware appliances. Once you've gone through a process of digitization, you can actually then replicate them with virtualized network functions. In doing that, then you string the VNFs together into something called a service chain, and you model that in Yang. And what that really does is it starts to make the ground system much more dynamic and closely resemble a software-defined network. Building on that, then you can completely automate the process of standing up and spinning down service chains through interfaces with common orchestration frameworks, whether that would be resource orchestration to running on common cloud environments or service orchestration with popular platforms like Cisco NSO or ONAP. So what this does is it allows us to not only digitize the entire ground system, but really embrace it with the proven philosophies that we've seen over the last decade with terrestrial networks in network function virtualization, software-defined networking, and cloud computing. Just real quick picture of what the network looks like. That's a lot of words. If you start here to the right of the network, you can see really a variety of constellations of satellites, GEOs, MEOs, and LEOs. They're all accessible via a gateway antenna. right on the left side of the antenna, you'll see a digitizer. And what that digitizer does, it does not modulate and demodulate. It generically digitizes in instantaneous bandwidth slices of 500 megahertz. Once digitized, then the digitizer will connect with a GigE switch and ultimately a pool of general compute. General compute is where the virtual network functions live, and as mentioned, they get spun up and spun down based on changes in the network design, based on changes in supply, changes in demand, and changes in threat. And this process is really handled by a digital ground controller, very similar to an SDN controller. That controller, being the brain of service chaining, is then driven by a digital ground manager, or it could be driven independently by a third-party service orchestrator such as ONAP or NSO. So that's just a really quick summary, but hopefully you guys enjoy it. And if you have any questions, you can always feel free to reach out directly to us at Kratos. We'd love to chat with you. Take care.